Hi, today I'm going to discuss about hardware cost of our products. In this video, I'm going to discuss about a little bit introduction about POSIT number system, and then it's a hardware cost, and then I'm going to pay a small animation of our CFA technology with and without. Yeah, so POSIT number systems are alternative to floating point number system, and so this has a lot of advantages in terms of accuracy, exceptions, and the dynamic range. So in the slide, you can see that on the top right there is uh, the plot, which is clearly exhibits the POSIT number and floating point comparison. So the posits are tapered precision. So in other words, they get more accurate near to 0 and 1 interval. So and since they have large dynamic range and there are no overflows and underflows, for your convenience I have plotted some closure plots for basic arithmetic operation, in this case addition, multiplication, reciprocal. So as you can see that posits are more accurate compared to floats. So in other words, they are get more accurate to the correct answer. For example, 0.36479 is the correct answer. In posits, you can say 0.3647888 is something like that. So the more closer the inexact results are. um, so exact results, in other words, which is matching the correct answer, you can see more than 18% on average in all of the closure plots. So and more inexact, in other words, closer to correct number, are more than 80% on average. However, in case of floats, that is not the case. There are some overflows and underflows as well, and in case of posit, there are not a number, and there are other exceptions as well. On the middle side, on the left side graph, you can see that I have plotted for different posit precision. Here posit 8 comma 0 is posit 8 bits. 0 means exponent 0 1 2 3 5. These are the exponent bits. uh, then plotted for the float comma 85 as well. So as you can see that posit 8 comma 1 seems to be promising for AI and machine learning applications. So usually in these applications you require 2 to 3 decimal places. So and the posit 8 comma 1 is the good candidate in AI and machine learning. In HPC or high performance computing, CFD or fluid dynamics, and weather pattern prediction, 32,2 posit 32 to 32,2 is the best candidate. So for other graphics computing, so 16,1 or 16,2 is the good candidate. Yeah. So in a state of the art processor, as you can see that usually in CPU and FPU are tightly coupled together. So you might be thinking how the posit unit can fit in this one. So the idea is to replace the current floating point unit with the posit coprocessor unit we call PCU. So just replacing a FP with a PCU, and then again issues that comes, how the compiler and how the programming model works. So we have solution for that. We have our own compiler called a Vivid compiler. So it is a C and C++ and a Fortran compiler. So the programmer do not need to change any of their programs or application. It works as it is. So we have a POSIT native compiler which can work seamlessly, uh, easily, and there is no work required on the application or programming side. So our products, I would say that replacing FPU with a PCU in most of the processors or accelerators. So you can see we have plotted, say, there are different hardware configuration for the posits. Posit 8 to posit 32, 8 bits to 32 bits, and then there are various ES bits. So on the left side you can see Vertex 7 FPGA. On the right side is the ASIC implementation of that. So the better candidates for AI and low power computing is a POSIT 8, 1 is the good um, good candidate, 8, 0 or 8, 1, 2. And so these plots for different the arithmetic operations, adder, multiplier, and divider. And you can see that POSIT 16, 1 is uh, suited for I would say the low-end computing, and it can also be suited for graphics computing or DSP application and so forth. The hardware utilization wise, you can compare that it's very minimal. In case of 8 comma 0, it's around LUTs around 500 LUTs. In case of 16, around 1000 LUTs. The same ratio goes for the ASIC was as well. uh, Around 1500 micrometer square for POSIT 8, 0, for 1500 micrometer square for um, 16, 1 as well. So you can see on the graph there are different configurations for different arithmetic operations. So we did compare with POSIT with floating point operations, floating point units. Um, there are a lot of paper out there which can do the same thing, so you can get many of that part. So you could see that POSIT 16 comma 2 or 16 comma 1 are um, uh, it's a better replacement for I would say 16 32-bit floats. And that is because this the in POSIT 16 comma 1, 16 comma 2, there are few extra bits that gives you the large dynamic range, and there are no overflows, underflows happening. So that can be a good candidate for that. So in terms of DSP utilized, you can say that there is a one DSP or utilized in 32-bit POSIT. It is a 4 DSP utilized, and the data path delay is around 30 nanoseconds. And 32-bit FP in 16-bit POSIT, you can say around 24 data path delay. The fraction bits are almost half. The LUT is utilized for 32-bit float is around 550 LUTs. In case of POSIT, it's a half. So you can see yourself in the comparison with better comparison between POSIT and floats. So this graph, this table is for the Racer GPU. We have implemented Racer GPU in ASIC 15 nanometer technology. This shows the table shows the implementation report of that. So it is running at 1.4 gigahertz, and it's consuming very minimal power, around 6.5 watt, and it can do 695 giga instructions per second. And it was implemented in a 16 nanometer technology, and the data path is a 32-bit. So it can do a lot of HPC or CFD, or high-end high performance mathematical computations. So the CFA technology, what we have is that uh, nowadays, that whenever we watch a movie or play a graphics or play a game, um, when we do that, the playing or watching a movie in a laptop or a mobile or any gadgets. So our as I may have seen that the battery goes down, drastically, and the processor fan starts, or your phone becomes getting heated. So that is because that it has to compute all of the, the video frame by frame. It's a matrix multiplication and matrix addition. So the addition in the state of the art processor is is sequential. It's gonna go from LSP to MSP. That is gonna consume a lot of power and the performance greedy as well. So the CFA eliminates this carry propagation. So thereby doing so that the power reduction going to be you know, um, the 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 power drawing from the circuits going to be much lesser than high performance. So I'm going to play a small animation clip of that so that you can understand or get a glimpse of how powerful CFA technology is. So as you can see, the bits are propagating from LSP to MSP. So these ones from LSP to MSCs are carry. So they are carry propagating from the least to most. So this is the problem in most of the processors or accelerators, and this is where the computation becomes power greedy and requires a lot of performance. And that's what you can see that in this clip uh, that the battery is going to drain down drastically. You can see on the bottom left side, and then fan on the right side is going to start. So that this clips gives you a glimpse of how it's uh, how it is draining power, and how the fan is, how the performance is going to affect it, and the processors and accelerators. So now I'm going to play a clip on using CFA technology. So in this the technology, the carry is going to detect it in advance. As you can see in the uh, this clip, the carry is detected in advance. These small ones on the top side, these small ones are carries. So detected in advance using CFA technology, and then some is detected, some is carried, or some is added using this carry. So since the sum is added in parallel, so there is no much perform the power drain. The throughput is going to increase in the circuit, um, and by the result of that, by the result of this, so the graphics or the movie, the what I'm showing the clip, the battery on the laptop or a mobile, it's not draining so fast. So um, that is the result, or the powerful of the CFA, and the processor. I would say it's not so much going to heat up. By result of that, since it's not going to heat up, the fan is going to be no, it's not going to start, or remain silent most of the time. So the product advantages are, our products are based on a posite number system, and there is a large dynamic range using this number system. So by doing so, there are no overflows and underflows, and there are very few exceptions. Since it requires the half the data width compared to the floating point, memory required is less, the silicon area required is less, the data width required is less. So the end result is less silicon area required, less power gonna be consumed, and this translates to longer battery duration, or in case of CPU or any digital uh, equipments, is gonna consume less power. Yeah, so that's it. If you have any questions on our products, or any concerns, please do let me know. I'll be more than happy to clarify your concerns. Thank you.